my friend Fahim and Vinay are your class in charges, isn't it?
Yes,
Yeah. So I would like to give you a few terms related to pharmacognosy today. Okay. One is what is a drug? What is a drug? Any one of you can answer this question? What is a drug?
Drug is a chemical substance.
Very good. Drug is a chemical substance. When in lower doses administered into our body, it will be capable of balancing your abnormal body function. Abnormal
Body function.
When the drugs are from natural sources, they are called as natural sources of drugs. Sometimes drugs may be invented, discovered. Invention and discovery, both are different two terms. Discovery is already existing drugs are found out and brought into use. When you find something new in the world, a new drug in the world, it will be called as invented drug. You understand? So, invention and discovery both will come under research of drug. Now, drug, what do you mean by a drug? Then what do you mean by a crude drug? An unrefined form of drug or a raw form of drugs are called as crude drugs. You understand? The pharmacognosy is a subject which deals with the study of drugs from natural sources. Or gaining a complete knowledge about natural sources of medicines. Clear now?
Yes.
You have an idea? So anybody who asks what is pharmacognosy, you should not hesitate to tell anything. Gaining knowledge about natural sources of medicine. So the main natural source of drug is plant. Plant kingdom is giving us a lot of medicinal substances. You understand? Yeah. Then coming down, animals, then the microbes, then the marine, and then the earth. These are 5 sources, right? Will combine together to give natural sources of medicine. They may be either natural or semi-synthetic in nature. We will get natural drug and we will modify in the laboratory and we will create semi-synthetic drugs. So synthetic is laboratory pure synthesis. In the laboratory, you are conducting a pure synthesis of medicine, preparing a medicine by using 2 natural chemicals or synthetic chemicals. But in case of a semi-synthetic, half of the drug will be obtained from natural sources and then it will undergo modification to prepare drug called a semi-synthetic drug.
Yes.
You understand? Yes. Then apart from, you are obtaining drugs naturally from plant, animal, microbes and marine and earth sources, mineral sources. They are all natural sources of medicines. Now you have a clear idea? So you are exposed to 3 or 4 important terminology what is pharmacognosy. Apart from that, 2 more terminology everybody must know is phytochemistry. What is it? Phytochemistry. Study of chemistry of plants. Chemical elaboration in plants is called as phytochemistry.
Yes.
Study of chemistry of plant. So a plant can be dealt in several perspectives. Sometimes botanical aspect, sometimes biochemical aspect, sometimes biogenetical aspect, sometimes pathological aspect, sometimes microbiological aspect, sometimes morphological aspect. Lichens which are symbiotically living on plant, microbiological aspect or biological aspect, symbiotical aspect. You understand?
Yes.
Likewise, if any infection occurs on the plant, we will deal it with pathological. Right? Likewise, when we study the structure of the plants, both microscopically and macroscopically, they are called as anatomy or morphology of drugs. You understand? Clear? So when you take a word, select your word, morphological study, which will include both macroscopic as well as organoleptic study. Combining called as morphological study. You understand? Likewise, anatomy can be either internal anatomy or external anatomy. The anatomical study of plants. Likewise, botanical aspect of plant, from which source they are obtained, what may be the specialities of or features of each and every organs, both internal and external. Right? And their sources and their classification will come under This botanical and taxonomical aspect. Likewise, biogenetical aspect. Biogenetic aspect. How the genetic makeup in each and every species when they are from lower family to higher family. Likewise, metabolites. There are two terms. Normally, metabolite presents any chemical compound which is being created in our body and is converted into other chemicals. The materials which are resulted from a metabolism is called as metabolites. But if it is going to be primary metabolite, they are created only for the makeup of our body and the plant body. Plant needs cells, plant needs organ, plant needs system, plant needs a whole tree or the whole morphology. For that build-up and growth function, the primary metabolites are very useful. They are carbohydrate, protein and fat. Clear? Yes. From carbohydrate, protein and fat, sometimes plant bodies are capable of creating some other chemicals. They are called as a specialized chemical called as secondary metabolites. They are called as secondary metabolites. They are given much importance in our pharmacognosy because the secondary metabolites are derived from various living beings of medicinal value, great medicinal value. Example, saponin, alkaloids. You understand?
Yes, sir.
Iodine, it's the saponin is saponin, right? Saponin. And likewise, flavonoids, right? They are all coming under flavonoid category. So, if you come to know about that, gums, it may be both primary as well as secondary. But it is going to be a simple molecular structure, primary, sugar derivative. If it is going to be a multiple gums and other derivative, we will call them a secondary metabolites because they are created in the plant for some other purposes, not for only nutrient purposes. You understand? Either it may regulate body function or it may have defensive mechanism or sometimes it may be a healing agent, sometimes it may be maintaining metabolism in the body. For other purposes, these secondary metabolites are created in plant for their defense to protect their body from the environment. But however, we human beings are extracting them and we are using them in smaller quantity in our body as drugs. They are called secondary metabolites. They are of several types. Alkaloids, glycosides, then steroids. The main categories are these three, right? And alkaloids, glycosides, steroids, flavonoids, gums and mucilage, resins and resin combinations. Clear? Yes. So you will terpenoids. You understand? Well, every big category is having phenolic compounds, mainly phenolic compounds, antioxidant effect as well as anti-inflammatory effect is very, very potential, right? In case of that kind of variety of components, right? Likewise, we are collecting a lot of secondary metabolites which are being used as drug, in which one of the drug we are studying today is okay, it's having secondary metabolites such as glycoside, especially diosgenin, saponin presence, so saponin glycoside. Yes. So if it is going to be a non-sugar moiety, genin. If it is a sugar moiety, sugar. Both will be added. A sugar, both will be added to form glycoside. Okay. So that iogenin moiety, maybe genin moiety. Okay. Likewise, sugar will mix it together. A genin connected together. Non-sugar, sugar moiety connected together to form a glycoside. Any sugar, when it is connected with another chemical compound, it may be probably a carbon group, automatically, or even amino group, whatever it may be. Any chemical compound which is being added with a sugar will become a glycoside and will be called as a glycoside. You understand? Yes. 4 types of glycosides are occurring in nature: C glycoside, N glycoside, S glycoside, O glycoside. Clear now? Likewise, for every glycoside, specific tests are available. Right? For saponin, specific tests are available. Clear? So, pharmacognosy students, surfacely must know at least these things. So one of the important instruments that you will come to use in the pharmacognosy laboratory is a microscope. The microscope may be of several types, in several versions. The oldest one is the normal dissection microscope. Normal dissection or simple dissection microscope. Understand? This is not having any kind of magnification except 5 or 10 times or x. X indicates times. Our visual capacity is up to see a material if it is weighing at least 200 micrometer. So your visual capacity is limited to 200 micrometer. You will be able to see only when a particle is measuring around 200 micrometer, 1/5 of 1 millimeter. 1/5 of 1 millimeter. If it is less than 1/5 of 1 millimeter or 200 micrometer, your eyes will not be able to see the material, or your naked eyes will not be able to see that particular material. And so you need to magnify that particular particle into bigger in size. So that you need some kind of optical instruments called as microscope. There are several versions from simple to advanced. The simplest is this one, normal dissection microscope. Usually the dissection microscope will be very useful in order to find out the impurities present in the crude drugs. If it is a bad excreta or insect excreta, mixing of some insect parts are there, you will be able to see very easily. Or if you want to study some microscopical or slightly enlarged surface beam of crude drugs, you can use this microscope, that's all. But if you want to go for the internal morphology or internal anatomy of a drug by taking section, either in the form of transfer or longitudinal, then you have to use an advanced microscope, either it may be of simple or compound. The simple microscope will give you 10 into 10 or 10 into 5, 50 to 100 times magnification. If you are going for a compound microscope, which will be having in the objective 3 types of powers, 10x, 45x, and the last one will be 100x. So 100 into 10, 45 into 10, eyepiece will be 10, into nose piece will be 10, 10 into 10, 100 times, 10 into 45, 450 times, 10 into 100, 1000 times. When a particle is enlarged 1000 times or 200 times or 450 times, you will be able to see the particle or the characters. You will be able to visualize very clearly and very pertinently and legibly. You understand? For that, these instruments are very, very useful called as a microscope, compound microscope. Next class I will join you, right? I will see how you are going to use compound microscope. There are rules how to hold the microscope and which screw or adjustment or stage adjustment, which finger or which hand is to be properly used conveniently. You cannot use both right hand for the adjustment of the stage as well as the screw. Both the side screw will be given. So one hand you have to use for screw, one hand you must use for stage adjustment. And under lower X, under lower power, how to focus the material and how the diaphragm should be open and to what extent, right? The mirror should be reflecting the light, or which mirror you have to select it, right? For natural light, which mirror, for artificial light, which mirror, and then any kind of measurement if you want to do, you have to use stage micrometer and eyepiece micrometer. How to calibrate eyepiece micrometer with stage micrometer? These are the fundamental part of microbiology. There is our pharmacognosy and phytochemistry. So when you proceed to microscopic experiment, you will call me. I will come and explain you how to use fundamentally a microscope. Once if you come to know the right method of using microscope, focusing will take only 10 minutes and you can show to the examiner. Or if you do not know how to use a microscope, even if you are working with microscope for 3 hours, you will not be able to focus even under a lower power. Clear now? Clear now? So next I will join you. Thank you.